First we have read this problem. A straight highway leads to the foot of a tower. Okay, so we have, this is the highway and this is the tower. Okay, and this is the highway from where some car is coming towards the tower. So here somebody is standing. A straight highway leads to the foot of a tower. Person standing on the top of the tower. So this is the top of the tower from where he is observing that a car is coming towards the tower. Okay. So first, when he observes with an angle of depression of 30 degrees, the car is located at A position. Now as he is standing there on the top of the tower, the car is moving with the uniform speed towards the bottom of the tower. So next, after 6 seconds, when he again observes the car, the angle of depression at this point, that is at B, the angle of depression is 60 degrees. So initially, when the car is located at position A, the angle of depression from where he is observing is 30 degrees. Now when he moved to location B, the car is moved towards location B, the time taken for the movement of the car from A to B is 6 seconds. Okay. Now when the car is at B, the observer who is standing at this place is observing with an angle of depression of 60 degrees. Okay. So here we have 30 degrees for A, 60 degrees for B. Now this angle of depression, alternate angles are equal, so here we get it as 30 degrees. Now this 60 degrees, which is the angle of depression for the position of the car at B. So that angle is, here we take alternate angles are equal 60 degrees. Okay. Now if you take the height of the tower is equal to h. Height of the tower is equal to h, and the distance between the bottom of the tower and the location B, we take it as x, and the distance between the first location of the car when the observer observed at an angle of 30 degrees and the position B when the observer observed at an angle of depression of 60 degrees, the distance between these two positions A and B is, we have taken it as D. Okay. So now we have h with respect to 60 degrees. The tower is opposite side of the right angle triangle. So here two right angle triangles are formed. One right angle triangle is nothing but A, C, and we can give the top of the tower where he is standing it as D. So two right angle triangles are formed. Two right angle triangles. Right angle triangles. One is triangle ACD. One triangle. Another triangle here we have is triangle. First one is ACD triangle. So this is AC, CD and AD or DA. This forms a right angle triangle with 90 degrees. That is triangle ACD. Another triangle which here formed is BCD. Another right angle triangle is BCD. Okay. At C we have 90 degrees. You can take it as DBC or DAC also. Like that also we can take, if getting confused with the C. So even you can take the triangle. Since we take the angle 30 degrees, so triangle DAC, because this is equal to angle A. And what is angle A here? It is nothing but 30 degrees. Another triangle which formed here is DBC. Okay. Triangle DBC, which is nothing but angle B, which is here we got it is 60 degrees. Now if you observe in this first triangle, this is first triangle we can take, this is the second triangle. So in BC, that is DBC triangle, to angle B opposite side is nothing but the tower. for this angle is 60 degrees, the opposite side, that is h height, is nothing but opposite side to the 60 degrees, and adjacent side to the 60 degrees, that is angle B, is nothing but x. So if you take tan of 60 degrees, tan of 60 degrees, that is length of opposite side, that is h, divided by length of adjacent side, that is x. Tan 60, that is for a specific ratio of an angle 60 degrees, opposite by adjacent, we have h by x, and we know that tan 60 is how much? Root 3. So root 3 is equal to h by x. So if you simplify and cross multiply this, x, you can keep h by root 3, or h is equal to root 3 into x, or x into root 3 is equal to h. Okay, just we are taking this x on the left hand side, the right hand side it is in the denominator. When it is taken on the left hand side, it comes in the numerator. So x into root 3 is equal to h. That is equation number 1. Now if you consider this tan 60 we got from which triangle here? DBC triangle. Okay, that also you can write here. From triangle DBC we got tan 60. Now another triangle here we have from triangle D, what it is? DAC. Another triangle here is DAC is the triangle. Okay, in this DAC we have angle A, it is nothing but 30 degrees. Angle A is DAC is the triangle, right angle triangle is DAC, where we have the angle A is equal to 30 degrees. Okay, so here we take the tan ratio itself again, because for 30 degrees angle we have opposite side again for 30 degrees also tower only, and the length of this opposite side is nothing but height of the tower. So tan 60 we got opposite by adjacent. Similarly tan 30 here is opposite by adjacent to tan 30 is complete A to C base. So I will draw this triangle here. So here for 30 degrees, this is D, this is A, and this is C. Okay, here somewhere we have the point B. So for this 30 degrees, that is for the right angle triangle DAC, opposite side again it is nothing but DC, which is nothing but H. Adjacent side to this 30 degrees is nothing but complete AC. A to C is nothing but the adjacent side to the angle 30 degrees. So from that, if you take tan of 30 degrees, it is what we get? Opposite side length, opposite length of the opposite side H, divided by AC, divided by AC. Now what is AC here? AC is nothing but sum of the distance from A to B and B to C. AC is equal to here, AC is this total distance. Okay, first position of the car to the bottom of the car, the total distance AC is adjacent side to the 30 degrees. Now AC we can write it as AB plus BC. We can write it as AB plus BC. Okay, so here in place of AC we can write it as AB plus BC. Now what here we have taken? AB we have taken it as D. Initially we have assumed it. How we got AB equal to D? We have assumed that the distance between first position of the car and the second position of the car, we have assumed it as D. And the distance between the second position of the car and bottom of the tower, that we have assumed it as X. So these two values are not given in the problem, that we have assumed it, that is X and D. And what they are asking here is find the time taken by the car to reach the foot of the tower from this point. Okay, that is X, time taken by the car to move from B to C. They have given the distance from A to B, the time taken for moving from A to B is 6 seconds. What they are asking here is to find the time taken for the car to move from B to C position. This time they are asking, what it is mentioned is the car is moving with uniform speed. So speed of the car is not changed when it is moving from A to B or B to C. The car is moving with uniform speed. Okay. So now H divided by AB. What is AB here? D. AB is nothing but D. And what is BC? It is equal to X. Okay. What is tan 30? Tan 30 is 1 by root 3. So 1 by root 3 is equal to H by D plus X. Now just simplify this and we can find what is H is equal to. So for that we just take cross multiply, not complete cross multiplication. Just take this D plus X on the left hand side and keep the H on the right hand side. So when we are taking the D plus X which is there on the right hand side denominator, it goes in the numerator of the left hand side. So we get it as D plus X by root 3 is equal to H. So again we got another equation here. H is equal to D plus X by root 3. So from equation 1 and 2 both are equal. From equation 1 and 2 what we got, this is also H is equal to X root 3. Here we got H is equal to X plus D by root 3. So this left hand side we can equate. The right hand side of equation 1 is H. The right hand side of equation 2 is H. Left hand sides also going to be equal. So from these two equations we can equate X root 3 is equal to D plus X by. So from equation 1 and 2 we can equate, because the right hand side of equation 1 is H and right hand side of equation 2 is H. The left hand side we can equate, that is X root 3 is equal to, where we have D plus X by root 3. So X root 3 we can equate it to D plus X by root 3. Now after that we just cross multiply this. So root 3 into root 3 we get it as X into root 3 into root 3. On the right hand side we have it as D plus X. This root 3 into root 3 we get it as root 3 square. So this square and root will get cancelled. So we have X into 3 is equal to D plus X. So we can write here it as D plus X is equal to 3x, and we can bring this x on the left hand side, so it becomes 3x minus x is equal to 2x. On the right hand side d is there, so 2x is equal to d, and from this we can write it as x equal to d by 2. So what we can observe from x equal to d by 2 is the distance between B and C is half of the distance of D. Half of the distance D. Okay. So here the time taken to cover the distance A to B is 6 seconds. Half of the time between B to C, the time taken is nothing but 3 seconds. So final answer we get here it as equal to 3 seconds. Thank you for watching and please subscribe. Okay, in this problem we have a statue stands on the top of a 2-meter tall pedestal. Okay, from a point on the ground, the angle of elevation of top of the statue is 60 degrees, and from the same point the angle of elevation of top of the pedestal is 45 degrees. Find the height of the statue they are asking. Okay, suppose somebody is standing at this point and the pedestal is located at here. The height of the pedestal what they have given is equal to 2 meters. On the pedestal the statue is positioned. Okay, so on the pedestal there is a statue here. So this is height of the pedestal is equal to 2 meters. Above this pedestal statue is present. Okay, now a person who is watching from a distance away from the statue or away from the pedestal is watching. Now first what they have given, the angle of elevation of top of the statue is 60 degrees. So this is top of the statue. So the angle of elevation is this. So we can join this person and the bottom of the pedestal. So the angle of elevation of this person who is looking at the top of the statue, first it is 60 degrees. Okay. Now from the same point he is standing, the person who is observing the statue is standing at the same point, you can take it as A. First he observed the top of the statue at an angle of elevation of 60 degrees. From the same point he observed the top of the pedestal is at an angle of 45 degrees. Top of the pedestal is at an angle of elevation. He is looking by raising his head. First he is raised his head, that is angle of elevation. Top of the statue 60 degrees. Top of the pedestal he is watching at an angle of elevation of 45 degrees. Okay. So this is given. What they are asking is find the height of the statue. That is this height they are asking to find. So if you take this as B and this we take it as C and this is you can take it as D. BD is the height of the pedestal. Okay. So now if you observe the opposite side to this angle 45 degrees is BD. And opposite side to angle 60 degrees is this complete BC. Okay, here we have two right angle triangles are formed. Two right angle triangles are formed here. One is ABC, you can take R. One is ABC. Okay, triangle ABC, one, and the angle here it is 60 degrees. This is 90 degrees. So this is triangle 1. Another triangle which is formed is ABD. Another triangle here which is formed is ABD. So this is triangle number 2. So the angle of elevation here it is 45 degrees. And DB they have given it as 2 meter, which is the height of the pedestal above which we have the statue. What they are asking to find is, here we have a point D, BD. Okay, this is BD 2 meters they have given. They are just asking to find what is CD. That is only height of the statue they are asking to find, that is H we have to find. Okay, so now AB we can find using that this angle 45 degrees we have, opposite to angle 45 degrees is 2 meters. And adjacent side we don't know, that we can calculate from this right angle triangle 2. Right here we have two triangles, one is ABC, you can write R, BAC triangle which is right angle triangle. Another triangle is BAD, triangle BAD is another triangle. So first from angle BAD, first we have triangle BAD. Here for this triangle angle A is how much it is? 45 degrees. This is important. In this triangle BAC, the angle of elevation angle A is 60 degrees, and in this triangle BAD the angle A is 45 degrees. That you have to differentiate. Okay. Now from this triangle BAD, if you take tan of 45 degrees, for this 45 degrees BD is opposite side. So length of the BD it is given 2 meters divided by adjacent side length, it is nothing but AB. We know that tan 45 is equal to 1. Tan 45 is equal to 1, which you have to remember. So 2 meters by AB. If you just cross multiply here, AB goes on the left hand side and we get AB is equal to 2 meters. AB is equal to 2 meters. Okay. So we got this complete AB, that is distance between foot of the pedestal, and it is same as the foot of the statue also. The distance between A and B we got from this triangle BAD or ABD, it is equal to how much? 2 meters. Okay. What they are asking is the height of the statue BDC. Height of the statue that we have to calculate is DC. So for calculating the height of the statue, we take another triangle we have, that is BAC. So from triangle BAC, or in this diagram BAC, we can take the ratio, tangential ratio, tan 60. Here why we are using tan? Because we have to calculate opposite side length and we know the adjacent side length. So we have the tan ratio is nothing but opposite side length by adjacent. Here you should not confuse the sine or cos, which you have to take, or tan. Tan we have to take because we have to calculate opposite side length and we know the adjacent side length. If you take cos or sine 60, that gives, if you take sine 60 opposite by hypotenuse, that we don't know. Cos if you take adjacent by hypotenuse, that also we don't know. And here we don't require to calculate AC distance. What here it is required to calculate is CD. DC they are asking to calculate. So we have to take the ratio of opposite side length by adjacent side length. That you have to remember. That's why we are taking it as tan 60, not sine, not cos. So tan 60 is nothing but, here if you look at this, already we have done triangle 1, triangle 2. Tan 60 we have complete BC. Total opposite to tan 60, it is nothing but BC, which is sum of BC. Here it is nothing but length, that is sum of BD and DC. 2. BD plus DC is equal to complete BC here we have. And BD we know. BD it is given it as height of the pedestal, it is BD. And DC we need to calculate, that is height of the statue. DC we need to calculate. Okay. Tan 60 is opposite side length, that is nothing but it is BC. Divided by adjacent to 60 degrees, again it is AB only. Adjacent side length, it is nothing but AB. In this tan 60, you have to remember tan 60 value, it is root 3. Tan 60 it is nothing but root 3. Tan 30 is 1 by root 3. Now here we got BC in the numerator. AB already we calculated here. AB is equal to 2 meters. You can write meters here, m, or at the end also you can write. So now what we want to calculate here is finally is DC, but DC is a part of BC. So first BC we calculate, BD we know, BC we got. From these two we can calculate the distance between D and C, that is height of the statue. So if we just cross multiply here, we get 2 into root 3 is equal to BC. 2 into root 3 is equal to BC we got. And what they are asking to find is nothing but DC. Okay. So from we have, you can write, we have total BC, total that is height of the pedestal plus height of the statue, that is BC is equal to BD plus DC. In this BC just now we got, okay, BC we got, that is 2 root 3. BC is equal to 2 root 3, and BD already we got, which they have given in the problem, that is equal to 2 meters. No need to write m here, 2 meters. Plus DC is nothing but height of the statue, which they are asking to calculate. So DC is height of the statue h. So you can write here some height of the statue. Height of the statue is equal to h, that is equal to DC. In the beginning you can write this statement. So 2 root 3 is equal to 2 plus h. Now if you bring this 2 on the left hand side, we get 2 root 3, already it is there, it is minus 2 is equal to h. Okay. What they are asked to find, 2 we can take out common from this and this. 2 into root 3 minus 1 is equal to h. Now we know what is root 3. Here you can stop solving the problem. H is equal to 2 into root 3 minus 1, or we have root 3 is equal to 1.71723. Okay. So root 3 minus 1 if you do, that is root 3 minus 1, 1.723 minus 1. So we get it as 0.723. That is root 3 this is 7, okay, root 3, we have root 3 is equal to 1.732. Root 3 is equal to 1.732. We have root 3 minus 1 is nothing but root 3 minus 1. 1.732 minus 1 we have to do, that gives 0.732. Okay, so here when we solve, h is equal to 2 into 0.732 is h. If you multiply these two, finally we get the height. So 2 2s are 4, 2 3s are 6, 2 7s are 14, that comes on the in place of 0, so we get 1.464 meters. So this is the height of the statue. Okay, thank you for watching. Please share and subscribe.